Okay, here we go. Yet another renewable energy resource video that I owe you guys. So let's talk about hydroelectric power when you can make all the jokes about dams that you want. So, as we've been doing, here is a diagram showing the percentage of a country's electricity production that comes from hydropower. Notice a few, probably to me at least, surprising ones. You've got Greenland up here, Norway. North Korea apparently uses a very large chunk of hydropower to produce its electricity. Up here with Venezuela, I think that's Uruguay. A number of countries in the southern half of Africa. I think this is Nepal. Um, I forgot which country this is, but you can see there is a significant chunk of countries in the world that are using hydropower to produce large amounts of their power. Brazil is using hydropower to produce between 60 and 80%, Canada as well. So let's talk about the most common method of using water to produce electricity, which is hydroelectric dams. So dams are built across rivers, and their job is to block the flow of water. To do that, they end up collecting water in reservoirs, and the water that's in those reservoirs has potential energy. Then you can allow that water to flow from the reservoir into through the dam to go downriver, and then it has kinetic energy. So it's going from potential to kinetic energy. And then that kinetic energy spins a turbine, which turns a generator that produces electricity. If you want to produce more electricity from a hydroelectric dam, you're going to need to build a taller dam, or you're going to have to allow more, larger volume of water to actually flow through the dam. So let's look at the energy transformations that are taking place here. You have potential energy built up in the reservoir water that transforms to kinetic energy as it's flowing through the gate, and also is kinetic energy when it's spinning a turbine, and then is converted to electric energy. So, very similar to what we've seen in a lot of our methods of electricity production, where you're turning a turbine, which powers a generator that produces electricity. Here are four of the largest dams in the world. So the Three Gorges Dam is the largest. It produces the largest amount of electricity, so 22.5 gigawatts of electricity. It's also a very large dam just by the amount of water that it's holding back. And then you have the Itaipu Dam in Paraguay, or it's actually along the border between Paraguay and Brazil, and it produces 14 gigawatts of electricity. It was built in 1984. I am totally going to mispronounce the Shiluodu Dam in China, which is going to be producing 13.9 gigawatts of electricity, and then the Belo Monte Dam in Brazil, which is located smack dab in the Amazon and is producing 11.2 gigawatts of electricity. So these dams are always major projects, which are going to cost a lot of money and are going to cause a lot of change in the local ecology of the river, which we'll talk about in a little bit. In contrast, there are some places where they're starting to use micro hydropower, where they place turbines that are smaller in rivers that don't necessarily block the whole flow, which would allow animals to continue to migrate and water to continue to flow without building up a reservoir. And they are just, single turbine or a couple of turbines that are being turned by the water that's moving through. Then there are other ways to produce water based electricity that are probably less familiar to you just because they're not as widespread as dams. So you have tidal power, which is going to use energy by the high tide and low tide movement of water, and it's powered by that natural rise and fall of the ocean tides and the currents going like in and out of bays and inlets and things like that. It's most effective where you have kind of a constricted area so you can get water to flow faster, because the higher velocity of that water, the more electricity you're going to be able to produce. Unfortunately, it's still a more experimental technology than, say, hydroelectric dams, so there aren't a ton of commercial scale production facilities, although I believe I have at least a picture of one. So there are a couple of ways that you can produce electricity using the tides. One is you have just these turbines that are sitting there in a bay or in an area, and as water goes inland with high tide, it spins the turbine, and as water goes outward with low tide, it spins the turbine again. These would allow movement of animals. You might have to make sure ships are careful around them, but it would have lower impact than a tidal barrage, which is a large barrier that's blocking the flow of water, and water has to move past a turbine in order to move with high tide and low tide. Those are very disruptive to ecosystems because they will block the movement of organisms. They're also a little more expensive to build, but they can produce some nice, reliable power. So a lot of the systems that are already in place to produce commercial electricity are these tidal barrage areas. And then you can create what's called a tidal lagoon, which is this third option. And you create this artificial lagoon and use the movement of water into and out of it during tides to produce electricity. Though I think there are only a few sites that use that. Then there's wave power, which is even more experimental, but it has a lot of potential to produce electricity if we can just get it to work. It uses the regular movement of water when it's producing waves, so water going up and down. This is driven by the wind. And this map right here shows the potential energy that could be generated from the motion of waves. So you'll notice there's some areas where there's a high potential energy, for example, in the northern Pacific Ocean, the northern Atlantic Ocean, and then in the areas around the Antarctic Circle, basically. However, this is not likely to be a huge impact on world energy production anytime in the near future because there's a lot of technical difficulties in trying to get this to work. So I'm not going to go over each of these. I'm just going to point out that there are multiple ways that you can try and produce power using waves. One that I had seen, but the company that was producing it has since shut down, uses the up and down motion of water as well as the side to side motion of water to drive some small turbines that can produce electricity. Here we have like a paddle being moved back and forth by waves that is connected to a hydraulic pump and a motor that can generate electricity. Here you have basically when water moves up inside this column, and then when it moves down, that's going to spin a generator, which is that's going to spin a turbine, which is going to turn a generator. And then I am not very sure about this type. I would have to look that up more. However, there's not a lot of commercial production of this. The first commercial waveform constructed was back in, I believe, around the early 2000s and around Scotland. There are a lot of different designs, but there are limitations in that it's expensive, and salt water is really corrosive to machinery. It breaks it down very easily. So you've got to find stuff that's resistant to salt water, and then you've got to get the power to shore. So, what are the environmental impacts of hydroelectric power? Well, one thing that's very good about it, it doesn't generate air pollution or waste, so it's not contributing as much to climate change. I'm going to bring up a point in a moment. The construction of these plants can be very expensive, so constructing dams, constructing tidal stations, etc. There's a lot of change to habitats following construction of dams because reservoirs flood large areas, which can displace people and animals. Another problem is when you build up these reservoirs, these large bodies of water, then you can get, especially if there's not a lot of movement in the water, these areas that are kind of more stagnant without a lot of oxygen. And so, without a lot of oxygen, anything that dies and kind of falls to the bottom gets broken down anaerobically. And the problem with that is anaerobic bacteria, when they're working on breaking stuff down, produce methane. And this methane is a greenhouse gas that we'll talk about more in Unit 9. And it's a more powerful greenhouse gas than CO2. So hydroelectric dams can contribute to climate change. Another thing is in reservoirs, silt is going to settle at the bottom of the reservoir so it doesn't reach downstream to floodplains, which can be very damaging to ecosystems. So, an example of how things change when a dam is built. This is the Three Gorges Dam, an aerial view in 1987 and 2006. Notice the difference between this area and this area, how much space has been flooded. People were living in those areas. The plant communities and animal communities that were in that area were displaced as well. So, it causes a large disruption to the areas upstream of the dam where the reservoir is going to fill up. So, in summary, what are some of the things that hydroelectric power can do? Well, with dams, once they're built, they have low operating and maintenance costs, and you can use them to control flooding downstream. So that way you don't have to release a ton of water. So downstream areas don't have to worry about, okay, it's flooding, we're going to have to evacuate. Doesn't produce polluting waste products, like doesn't produce sulfur compounds or nitrogen compounds. They have a very long lifespan. They can be in existence as long as they're not damaged by earthquakes or anything else, and they're well built. They can exist for decades. And they get pretty high energy yields, moderate to high energy yields for the energy that's being released. They also create lakes. Those are the reservoirs that can be used for water, to provide drinking water, for example, to neighboring cities and also recreation. For example, almost all of the lakes here in North Texas are created artificially by damming up mostly tributaries of the Trinity River. There's only one naturally occurring lake called Caddo Lake. So unless you live near Caddo Lake, any lakes you go to for fun or fishing or swimming or anything, those are all due to dams. The cons, however, are the large flooded areas can displace people, damage habitats. There's also the problem of preventing fish migration, slow moving water. When water reaches a dam, it's stopped, so it's losing its velocity. And when you have slow moving water, you can have pathogens, disease causing organisms there. For example, stagnant water or non-moving water is where mosquitoes will breed a lot. So if you're trying to prevent disease spread by mosquitoes, you don't want to have ponds and large lakes build up. Another thing, since sediments don't reach downstream areas, they build up in the reservoir and then you have to dredge them periodically, which means dragging out all that dirt that builds up at the bottom and dumping it somewhere. They are very expensive to build. They're large scale projects, which means that usually you're going to have a government or a large company is going to have to be able to build that. This is not something that a smaller group can do. And if you have a very large project, if you have earthquakes in the area, they can damage the dams, and that can cause serious problems as well. So here is the end of hydroelectric power.